So is my screen visible to everyone? Is my screen visible? If you see the chat box. Am I audible to everyone? Is my screen visible? Yes. Am I audible? Okay, so in today's session, we are going to discuss the paper, what you wrote yesterday. Okay, have you all attended the exam? Mock test 4, how many of you have attended? How many of you have attended the mock test 4 paper? Put it in the chat box. How many of you have attended the paper? None of you have attended. Put it in the chat box, right? Have you attended the exam?
Yes, ma'am, I have attended.
Okay. Who else have attended? How was the paper? How was the paper?
Ma'am, it was as usual as tough.
Okay, fine, fine. So I'll invite the rest students to the class. Okay, fine. Yes. So I have sent a message, so we'll start the class today. So moving with the first question. Okay, so look the question. It is the vapor pressure of benzene, toluene, and the xylene are given. Which of the following is not a possible value of the vapor pressure for an equimolar solution, ternary solution of these at 20 degrees Celsius? Okay, have you attended the question? What was the answer? Like, put it in the chat box. What was the answer? Have you attended the question? What was the answer for this question? The vapor pressure of benzene, toluene, and xylene are given as 75, 22, and 10. Okay. Which of the following is not a possible value of the vapor pressure of an equimolar binary or ternary solution of these at 20 degrees Celsius? Take all solutions as ideal in nature. Very good, very good. Yes, it is like D. D is the answer. Okay. So we'll solve this question. So what are the possible binary solutions first? The possible binary solutions. What are the possible binary solutions? What are the possible binary solutions? So here they have given like it is ideal in nature. So you have to select the ideal solution. Yes. So now we know that like while discussing the questions in solution unit, I have told you like how to identify the ideal and non-ideal solution, which will give positive deviation, which will give negative deviation. We have done. Yes. So for ideal solution will be always homologous. Homologous. Okay. It means that like its functional group would be same. Okay. Those solutions are said to be as ideal solutions. So here I have like benzene, toluene, xylene. So everything has a double bond, right? It has, these are the homologous of benzene only, right? So, what are the possible binary solutions? The first one is like benzene plus toluene. Benzene plus toluene. The second one is like benzene plus xylene. Xylene. And the third one is toluene plus xylene. So you can get like one binary solution. Okay. And how many ternary solution you can get? Like they have asked for binary and ternary. So ternary means like three solutions. So all the three solutions, I'll be getting it as like benzene plus toluene plus xylene. Okay. And you can see a word equimolar is given. So what is meant by like equimolar? The equimolar solution will have the mole fraction. For binary solution, its mole fraction will be like 1/2. And for ternary solution, it will be like 1/2. Okay. So first, I'm taking it for like benzene and toluene. So what would be the like Pc will be equal to, okay, the pressure will be equal to 1/2. Since it is a binary solution, I'm taking it as 1/2 and plus 1/2 into toluene vapor pressure is 20. Okay, so you'll be getting it as like 48 1/2 will be getting. Okay, so it will be like 97/2, which is nothing but 48 into 1/2. And now moving to the second one. So benzene plus xylene. So benzene value is 1/2 into 75 plus xylene. What is the value given? It is like 10. So 1/2 into 10, which is 85/2. So when you evaluate over here, you'll be getting it as like 45.2. 45.2. Okay. And next is, sorry, 42.5. And next is like toluene plus xylene. Toluene plus xylene is P is equal to 1/2 into 22 plus 1/2 into 10, which is equal to like 16 will be done. Okay. Ternary solution, it is, if it is equimolar, then it will be like one third. So 1/3 into 75 plus 22 plus 10, which is 107/3, which is 35/2. Okay. So which value you didn't get over here is like 53 1/2 is the value. 48 1/2 you have got. And 16 you have got. 35 2/3 you have got. So all the three values you have got. And which of the following is not a possible value is the question. Not a possible value is the question. So 53 1/2 is not a possible value. So option B is going to be the right answer. Okay, got with this question, everyone? Are you clear with this question? Yes. Shall I move to the next question? Are you all clear? Are you all clear? Question. Of the following, which will not show the chromyl fluoride test? Which will not show the chromyl fluoride test is the question. Okay. So you have like rubidium fluoride, and here you have a complex like K2PtCl6 and show the chromyl chloride test is the question, which will not show, which do not show the chromyl chloride. Okay, so what would be the answer? Like anyone can put the answer for this question? What would be the answer for the question? What would be the answer? Put the answer in the chat box. Put the answer in the chat box. Fine. So first, you have to understand like what is chromyl chloride test. So for identifying which ion this chromyl chloride test has been, for identifying which ion this chromyl chloride test is used, From the name itself, you can say it is used to identify the chloride ion. Okay, Cl minus ion. Okay, so what is the reagent you are going to use in chromyl chloride test? So you are going to heat the chloride salt with potassium dichromate, K2Cr2O7. You'll be getting, in presence of sulfuric acid, you'll be getting chromyl chloride, CrO2Cl2. Out like the red fumes. So if it is a chloride salt, you'll be getting red fumes of chromyl chloride. If not, if the salt is not chloride salt, then you will not get the red fumes. Okay. So this is chromyl chloride. Okay. So here the chloride ion is reacting. Chloride ion is reacting. So what you have to do in the four options, you have to check like which one will give out the chloride ion. Okay. So rubidium chloride, whether it is like ionic salt or covalent salt. We know that ionic salt will give out the ions, right? So rubidium chloride is ionic or covalent? Rubidium chloride is ionic or covalent? It is ionic, right? It is ionic. So it is an S block. So it is going to be like ionic in nature. So it will give out Cl minus ion. Now moving with benzene diazonium chloride. What is benzene diazonium chloride? N2 plus Cl minus. So it can also give out Cl minus because it is ionic in nature. It is ionic. Okay. So what about like K2 PgCl6? Now, will the complex give out the Cl minus ion? Will the complex give out the Cl minus ion? No, it will not give. Yes. So because like this one here, the bond is like very strong. Okay, which is ionic part over here. Like you'll be, when you dissociate this one, you'll be getting it as like 2K plus PgCl6Q minus. So chloride ion will not come out. Okay, this is the ionic bond. So this will be your counter ionic part. Whereas the whole thing is your complex ion. Okay. So if Cl minus comes out, then we'll not be telling it as the complex. We'll be telling it as the double salt. Okay. So since it is the complex, it do not give out. It do not give Cl minus ion. So here option 3 will be one answer. And when you like look into mercurous chloride, okay, HgCl2. So mercurous chloride, whether it is like ionic salt or a covalent salt, mercurous chloride. Mercurous chloride is ionic or covalent? It is covalent. It is covalent. So will it give like Cl minus? The covalent bond is formed by mutual sharing of electrons. So it will not give. So 3 and 4 will not give Cl minus ion. So the option is going to be like, okay. So everyone got this question? Clear with this question? So only ionic compounds will give out Cl minus. So that one will show the chromyl chloride test. If it is a complex or if it is a covalent bond compounds, then they will not give Cl minus ion. So therefore, this chromyl chloride will not be. Yes, clear with this question, everyone? Shall I move to the next question? Clear with this question? Yes, fine. So moving to the next question. Okay, so look into this question. Here, referring to figure 1, identify 3 spots obtained by electrophoresis at pH is equal to 7 of a mixture of the Fruitans pepsin, whose pH value is 1.1, hemoglobin, whose pH value is 6.8, and lysosome, whose pH value is 11.0. Okay. So here in electrophoresis, what happens in electrophoresis? So this question is from surface chemistry. Okay, so what happens during the electrophoresis reaction? There will be like 2 electrodes. Okay, there will be like 2 electrodes. Positive electrode is cathode or anode. What is positive electrode? Cathode or anode? Positive electrode is cathode or anode? Positive electrode is cathode or anode? Hey, students, are you there? Like, tell me what is positive electrode, whether it is a cathode or anode. Yes. So we know that anion is having minus charge. So it will move to the positive electrode, which is your anode. Which is your anode. To the negative electrode, which is the cathode. Okay. So now, which of the following options are correct about the position of various proton molecules? Okay. So they have given, like, using the pH value, you have to identify. So now I'm moving with pH is equal to 1.1. pH is equal to 1.1, whether it is in the acidic range or in the basic range. pH is equal to 1.1, whether it is acidic range or basic range. pH is equal to 1.1 is acidic range or basic range? Very good. It is acidic range. It is acidic range. So it means that it has more anion groups, more anionic groups at pH is equal to 7. So therefore, it will migrate to the positive electrode. So if pH is equal to acidic range, it will move towards the positive electrode. That is your anode. That is your anode. Okay. Now moving to the second pH. What is the second pH value? Is 6.8. 6.8. So here the net value is it is like mostly close to the net charge. Okay, zero net charge. So it will not migrate at all. It do not migrate. Okay, because it is like near to pH is equal to 7. So it will not migrate at all. Now, if the pH value is equal to 11.0, if the pH value is equal to 11.0, it means that it is like basic. Okay, pH is equal to 11.0 is a very basic condition. pH is equal to 1.1 is an acidic condition. So when the ion is like acidic, it will move to the positive electrode. So when the pH value is very basic in nature, so it mainly exists in which form? Cationic form. Okay, so therefore it will move to the negative electrode. It will move to the negative electrode. Okay, so now you can just look out the options and tell me like which would be the correct answer. Look out the options and tell me like which is the correct answer. So I have given few hints. Okay, so if pH is equal to 1.1, it will move to the positive electrode. That is your anode. Okay, so look over here. Lysosome is like 11.0. It will be present at spot A. So spot A is nearer to anode. That is your positive electrode. So if 11.0 basic, where it will move to the negative electrode. Okay, so lysosome should be present at the spot C, not at A. At C is nearer to the negative electrode. Okay, so it should be like nearer to spot C, not A. So this option is going to be wrong. And pepsin will be present at spot B. At spot B. Spot B is like, it should be for hemoglobin. It should be for hemoglobin because like it will not, it is like in the middle. Okay, so it will be for the hemoglobin. Okay, spot C is for lysosome. So pepsin will be present at spot A. So see, pepsin is like very acidic in nature, so it will move to the positive electrode. So it have migrated to the positive electrode. That is your anode. So here will be pepsin present. Pepsin. So option C is going to be like right one. Okay, hemoglobin will be present at spot C. Hemoglobin, since its pH is 6.8, it will not migrate to the negative electrode. So therefore, this option is also going to be wrong. So option C is going to be the right answer. Okay, got with this question, everyone? Are you clear with this question? So if pH is like very acidic, it will move to the positive electrode. If pH is like very basic, it will move to the negative electrode. And if pH is equal to like 7, it will not migrate at all. Okay, clear with this question, everyone? Clear with this question? Any doubts with this question? Shall I move to the next question? Yes, fine. So moving to the next question. Next question is, silver sulfide dissolves in sodium cyanide solution to form the complex Na2AgCN4, NaAgCN twice, Na3AgCN4, and Na3AgCN. Okay, so now what would be your answer? What would be your answer? Have you attended this question? If you have attended, like put the answer in the chat box. Silver sulfide dissolves in sodium cyanide solution to form the complex. Okay, so we'll go with the answer. So silver sulfide, okay, silver sulfide, it dissolves in sodium cyanide, where sodium cyanide is like highly reactive. It is highly reactive. Okay, it is highly reactive. This is because NaCN. Yes. So now when you check this, nitrogen is highly electronegative in nature. It will pull the electron towards itself. Yes. So therefore, this carbon will have a partial positive charge, and this nitrogen will have a partial negative charge. Okay. So now, like this one is ionic in nature, so it can get into Na plus and Cn minus. Na plus and Cn minus. So this sodium cyanide is highly reactive towards metal. It is highly reactive towards metal, and it will dissolve the metal into its corresponding cyanide form. So when it like reacts with silver, okay, here the metal given in the question is silver. So when it reacts with silver, it will form the cyanide of silver. Okay, the metal cyanide form it will form. So this metal cyanide form, it is like soluble. Okay, it is like soluble. It is not insoluble, it is soluble. So it is used to extract the pure metal. Okay, so this what we have to find out is, what is the complex of sodium cyanide form is the question. Okay, so now we know that like sodium cyanide is highly reactive, so it can dissolve in it can like react with the metal. It is highly reactive towards the metal. Okay, so what happens over here, we'll see. Like silver, NaCN will give you like Cn minus, so silver sulfide will give you like Ag. Okay, so now this silver will react with Cn minus. It is soluble. Okay, so in presence of water, it will give you AgCN2 2 minus. So this is the complex form, AgCN2 2 minus. Okay, so this one is the complex form. Okay, so therefore, what would be your answer? What would be your answer? AgCN2 2 minus. So which one will give you this complex? Which one will give you the complex? Okay, so we'll balance this equation, so it will be like easier. 4 times of Ag plus 8Cn minus will give you 4 AgCN2 2 minus plus 4 times of OH minus will move out. 4 times of OH minus will move out. So what would be the complex form? What would be the complex form? Which option is going to be like right? Which option is going to be like right one? Okay, so when you take this, okay, so you have like Ag, sorry, it should be like 4, Cn4, 4, 4, 16. So 16 Cn minus, okay. So therefore, AgCN4 minus. So it will react with 2 times of Na plus to form Na2AgCN4. CN4. So option A is going to be the right one. Okay. So this question is from metallurgy. Metallurgy. Okay. So have you like gone through metallurgy? There is one reaction called MacArthur forest cyanide process. Forest cyanide process. So this is like used to extract the silver. This method is used to extract silver. Okay. So what they will do is like this, you'll be taking a silver ore and react with it with NaCN. Here the silver ore is like silver sulfide. Okay. So it will form a soluble complex like this, AgCN4 minus. Now what you want a pure silver. So again, when you react it with zinc, this zinc will combine with CN4, okay, 2 minus, and pure silver you'll be getting the pure silver. Okay, so it is used to extract pure silver, and the reaction with the zinc is known as like cementation. This process is said to be a cementation process. Okay, it is used to extract silver. So this is MacArthur forest cyanide process. Okay, clear with this question? So have you like gone through the metallurgy unit? Then you'll be clear with this. Like isolation of metals. Fine. So moving to the next question. So look over this question. So you have to match it with the process with the equations. Okay, so what are the equations given? Adiabatic process, isotope equation. So you're going to match with it. Okay, so here more than like one option could also be right for the same process. Okay, so which would be the answer? Like, put your answer in the chat box. Put your answer in the chat box. I'll wait for a second. Evaluate and put the answer in the chat box. Any guesses? What would be the answer? Like evaluate one by one. Okay, so it is an isothermal reversible process. So for isothermal reversible process, which among the equation is going to be like right? So for isothermal reversible process, what would be the work done? Work done is equal to minus nRT into ln of V2 by V1. Yes. So this is the equation for isothermal reversible process. So option 4 is going to be right. And also like you can do one more equation. It is isothermal. It means that what is going to remain constant for an isothermal process? Which is going to be like remain constant for an isothermal process? Very good. Temperature is going to remain constant. Okay, temperature is going to remain constant. So now, like when you write the first law of thermodynamics, delta U is equal to Q plus W. Delta U is equal to Q plus W. Yes, fine. So delta U is equal to 0 is also going to be the right answer. Okay. So we know that here Q is equal to minus W. Yes, Q is equal to minus W, which is nRT ln V2 by V1. So here temperature is going to be like remain 0. Temperature is going to be like remain 0. So the whole term is 0. So delta U will also be 0. So 4 and 5. So P could be matched with 4 and 5. Very good. Now, adiabatic process. For adiabatic process, what would be the equation for adiabatic process? For adiabatic process, which is going to remain constant for adiabatic process? For isothermal, temperature is constant. Temperature is constant. For adiabatic process, which will remain constant? For adiabatic process, which will remain constant? Very good. Q is equal to 0. Q is equal to 0. So when I like put it in first law of thermodynamics, delta U is equal to Q plus W. So what would be delta U? Q is going to remain it with third one. You are getting W is equal to delta U. So third. Okay, so Q is 3. And isobaric process. So for isobaric process, which will remain constant for isobaric process, bar is the unit of pressure. Yes. So isobaric process, P will be remaining 0. Okay. So the change in pressure is going to remain as 0. Okay. So now when you evaluate over here, we know that delta U is equal to Q plus W. Yes, delta U is equal to Q plus W. So delta U is equal to Q plus W. So therefore, and again, like we know that what is work done? Work done is equal to minus P into delta V. So when you see over here, pressure term is there. Pressure term is there. But here, the change in pressure is going to be like 0. Change in pressure is going to be like 0. Here, pressure, it remains constant. Pressure, it remains constant. So therefore, R will be equal to 2. Now, moving with isochoric process. What is isochoric process? The change in volume will be equal to 0. Isochor. So isochor means that concentration is going to remain like 0. So therefore, delta V will be equal to 0. So the whole work is going to be like 0. So delta U is equal to Q. So option 1. Okay. So isothermal reversible process is 4, 5. Adiabatic process is 3. Isobaric process is 2. Isochoric process is 1. So option A is going to be the right answer. Okay. Clear with this question, everyone? Clear? Yes. Moving with the next question. Okay. So look over this question. In the first list, they have given the shape, hybridization, whether they are isoelectronic or not. And in the second list, you are going to match these things with the compounds listed in 2. Okay. So now can you guess the option? You have to find out like which all have the linear shape, which all have the sp hybridization, which all have the sp3d hybridization, and which are all like isoelectronic species. You have to match. What would be the answer? I'll wait for a minute. Like evaluate and do it. Like this question is easy one. You can give the answer. Like do it in your notebook. Give the answer fast. This question is very easy question. If you do the first one right, you'll get some idea like which will have the linear shape and what would be its hybridization. If you do it like, you'll get the answer easily. Make it fast. Okay, so which all have the linear shape? CO2, CO2. I'm writing each and every shape, okay? So it is O, write the Lewis structure. So O double bond, C double bond. Yes. So what type it belongs to? It belongs to like AB2 type. What is the geometry for AB2 type? What is the geometry of AB2 type? What is the geometry of AB2 type? Linear. Very good. Linear. And we'll write the hybridization too. So what is the hybridization over here? How many sigma bond you have? You have only 2 sigma bonds. So the hybridization is going to be sp. Now moving with ICl2 minus. Write the Lewis structure for ICl2 minus. ICl2 minus. So write the Lewis structure 1, 2, 3, 4, 5, 6, 7. You have like minus over here. So I'm making one pillar. AB2 E3 type or L3 type. You have like 3 lone pairs. So what is the geometry of AB2 E3 type? What is the geometry of AB2 E3 type or L3 type? What is the geometry? Just go through the VSEPR theory. Yes. What is the geometry of AB2 E3 type? It is also going to be like linear only. Okay, it is going to be like linear. So therefore, what is the hybridization over here? So it is linear. So I'll draw the molecule linear. ClC. Yes. So what is the hybridization over here? You have like 2 sigma bond and 3 lone pairs. So totally it is going to be like 5. It is 5. So you'll be having like sp3d. Okay. So sp3d is the hybridization. Now moving with like C2H2. What is C2H2? C2H2 is acetylene. Yes. So acetylene is CH triple bond CH. So for CH triple bond CH, it is like very good. Linear and sp. Linear and sp hybridization. And moving with like NCO minus. NCO minus. So NCO minus. Now again, it is like of AB2 type, linear and sp. DF2, DF2. What is the type of DF2? It is again linear S. Okay. So just match with this now. Which all have the linear shape. All the 5 compounds have the linear shape. So linear shape is for like 1, 2, 3, 4, 5. And moving with sp hybridization. So which have like sp, A, first one has, third one has, fourth one has, and fifth one has. Only second one doesn't have the sp hybridization. Which has the sp3d hybridization? Second one. So which among the 5 are isoelectronic series? What is meant by like isoelectronic? What is isoelectronic? What is isoelectronic? Same number of electrons. Same number of electrons. Very good. So now when I take like CO2, what is the number of electrons on carbon? 6. And what is the number of electrons on oxygen is 8 plus 8. So it will be like 16 plus 6. So what is the total number of electrons? It's going to be like 32. Yes, 32. So which among the following has 32 number of electrons is the question. Okay, so just evaluate and tell me like among 5 which has the 32 number of electrons. Just do it for everyone. Count the number of electrons of all the atoms. Of all the atoms. Isoelectronic species, you'll be counting the number of electrons for all the atoms. See here, everything, it belongs to group 17, right? Iodine, fluorine. So what would be the number of electrons? So the number of electrons is going to be like higher. Okay.
And when you take like CH triple bond, CH 6, 6, 12, 13, 4, 10 only. So it will not be. Like when I take NCO minus, so here it is like 6, 8, 7, minus 1. So you have to add 1. Okay. Like negative charge, you have to add 1. If there is a positive charge, you have to minus, like C. Okay, C. Sorry, 22. 22, yes. And next is like BF2. BF2. So what would be the number of electrons? So 9. Is there no roll of bond, just valence one? Yes, 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 yes. So it is like 9, 9. And what is the atomic number? Like take the atomic number and add it together. That's it. For isoelectronic species, what you're going to do is like write the atomic number of each and every atom and add it together. Okay. Only be careful, like when there is a negative charge, you have to add 1. If there is a positive charge, you have to minus 1 electron. Okay. So that is like, if it is like +2, you have to minus 2 electron. If it is like -3, you have to add 3 electrons. Okay. So that is the only thing you have to remember. So else you have to just add the atomic numbers together. Yes, fine. So now what is the atomic number of beryllium? It is 4. So 9, 4 is 13. 13 plus 9 again is going to be like 22. So which all have the same number of electron is 1, 4, and 5. So which option is going to be like right one? Which option is having all these things? 1, 2, 3, 4, 5. 1, 3, 4, 5. Yes, it is going to be like option number C. Okay. So option C has all the things right. Clear with this question, everyone? This is like some easy question only. Clear? Clear with this question? Fine. So moving to the next question. Yes. So this question, like, it is from the chemical kinetics. Yes. Negative sign used in expressing the rate of the reaction indicates that unit of rate of reaction is the rate of reaction and equilibrium constant Kp for an exothermic reaction. You're just going to match it with the options. Okay. So just match with options and get me the answer. You're just going to match it with the options. Match with the options. Negative sign used in expressing the rate of a reaction indicates that. So while we are writing the rate of reaction, so rate of reaction is equal to minus D concentration of by dt. We'll be writing like this, right? So what does this negative sign indicates? It indicates that which is going to be like right. It indicates increase with increase in temperature or independent of pressure, concentration of reactant is decreasing with time, independent of concentration. It indicates that the concentration of reactant is decreasing with time. Okay, so when there is a reactant, as time goes by, it gets converted to product. So what happens to the concentration of the reactant? It gets decreased. Okay, so it indicates that the concentration of the reactant decreases with time. So P is going to be like 4. Now, unit of rate of reaction. So among this, which is unit of rate of reaction? This one. So 1. And what is like rate of reaction? Rate of reaction, what happens? It will increase with increase in temperature, or it is independent of pressure, or it is independent of concentration. Rate of reaction. It increases with increase in temperature. Yes, 2. Equilibrium constant for an exothermic reaction. For an exothermic reaction, what happens? For an exothermic reaction, what happens? Yes, it is independent of concentration and also it is independent of pressure. It depends only on the temperature. It depends only on the temperature. So S is going to be like 3 and 5. Okay. So which is going to be the right answer? Again, option C is going to be the right answer. So P4, Q1, R2, S3. And yes. So clear with this question? Clear with this question, everyone? Yes. So moving to the next question. Okay, so this is also like easy question only. You have few terms and you have the formulas on the right side. Okay, few terms on the left side. You're just going to match with it. So which is going to be right? Equilibrium constant part. Okay, I'll explain. Yes. Equilibrium constant, this part, right? Yes. So they have told like for an exothermic reaction. So for an exothermic reaction, see, this question is on the Le Chatelier's principle. Le Chatelier's principle. Yes. So in Le Chatelier, what is Le Chatelier's principle? Whenever a system is disturbed, okay, whenever a system is disturbed, that is like when you're increasing the concentration of the product, or when you increase the temperature, decrease the temperature, or when you like increase the pressure or decrease the pressure, what happens? The equilibrium will just adjust to maintain the equilibrium state. Okay, so it will just, if a stress is applied, okay, if you're doing some disturbance to the equilibrium state, it itself will adjust to maintain the equilibrium. That is like Le Chatelier's principle. So for exothermic reaction, like what is exothermic reaction? What is exothermic reaction? Heat will, what is exothermic reaction? Heat will evolve. Heat will evolve. Okay, so now if there is a system like A gives B plus heat is going out. So therefore, this is the forward reaction is going to be like exothermic. What would be the backward reaction? The backward reaction is going to be like endothermic reaction. Yes, backward reaction is going to be like endothermic. So A to B is exothermic, B to A is going to be like endothermic. Now, for an exothermic reaction is like when you're giving the heat out. Okay. So now what happens when you increase the heat? When the temperature is increased, it means that it will take up the temperature what you are increasing and go back to A, and it will go back to A. So what happens when the temperature is decreased? It means that it just adjusts to the forward reaction. So as the temperature decreases, okay, so which is favored? Like exothermic is favored. When temperature is increased, then endothermic side will be favored. Okay, so here exothermic side is like forward reaction. So A will give more amount of B, okay, by evolving the heat out. And when the heat temperature is increased, the B will like absorb, take up heat. Here you can see and give back. Okay, so which is favored? Backward reaction is favored. It will take up the heat and give back heat. So this is in case of like the temperature. So here it does not depend on the pressure. So that is why the option 3 and 5 are ordered. Okay, got with this? Clear now? Yes. Moving with the next question. So the next question is, you're going to match these terms with the formula C. Okay. So just have you got like this is not lambda, this is L by E. This is L by E. It is not lambda. It is L by E. Yes. Have you done with the matching? Just try this question. This is like easy question. Just you're going to match with the terms which is given, which is like very well known to you. This is from electrochemistry part. Okay, what is Faraday's first law? The mass is directly proportional to the charge, right? So here, like, what is the amount of charge you're passing? That much amount of mass will get liberated as the Faraday's first law. So what is the equation for it? The mass, that is weight, is equal to I into Z into C, where Z is the equivalent and I is the amount of current you're passing at time. Okay, so therefore P is going to be like 1. And what is like 1 Faraday? 1 Faraday is equal to how many coulombs? We know that it is equal to 96,500 coulombs. So 3. What is cell constant? Cell constant. What is cell constant? So if you have a cell, okay, cell constant is the length of the cell into its area. The length of the cell by area. So the ratio of L by A is the cell constant. So here it is going to be like option 4. And what is conductivity? What is conductivity? What is conductivity? It is 1 by resistance, right? Yes. So it is going to be like 1. So option B is going to be the right answer. Fine. And next question. Identify the incorrect statement. So this question, like, it is more than one correct option. More than one correct options. Okay. So you will be having like 2 to 3 questions based on this. More than one correct option. 3 questions. Okay. The next 3 questions are more than one correct options. Yes. Identify the incorrect statement. Identify the incorrect statement, which is going to be like wrong. Okay. So look for the first one. The ratio of the absorbed molar volume to ideal volume under similar condition is called compressibility factor. So this question is from gaseous state. Compressibility factor is Z is equal to the molar volume of ideal ratio of the absorbed molar volume to ideal volume and the factor. So here it is given as like real. Okay, so real by ideal. Ideal volume. So molar volume is the real volume and by the ideal volume is called the compressibility factor. Is it true or not? Real by ideal is the compressibility factor. So it is true. And the value of Van der Waals constant A and B is independent of the nature of the gas. Are they independent or dependent? Van der Waals constant will be like PV is equal to nRT. Yes. So for a real gas, like it will not obey this ideal gas equation. So this correction term is like A and B gives the correction term. So it depends on the nature of the gas. So this one is like incorrect statement. This is correct statement and this is incorrect statement. B is incorrect statement. Now, at high temperature and low pressure, T plus, this is your Van der Waals equation, right? T plus A n square by V square, V minus NB is equal to nRT. You can see like A and B terms over there. That is what given here. Van der Waals constant A and B. Okay. Is used to explain the behavior of any gas. The behavior of any gas at high temperature and low pressure is given by what? PV is equal to nR. At high temperature and low pressure, the gas follows PV is equal to nRT. When it will follow this Van der Waals equation at low temperature and high pressure. So this statement is incorrect. Now, hydrogen and helium gases are difficult to liquefy because their critical temperature is very small. Is this true? Like when you take the gases which is formed on its own, like helium, hydrogen, N2 gas, O2 gas, right? So these gases, like all the noble gases, these gases will have, they are like difficult to liquefy. It means that you can't convert it into the liquid state easily because of its critical temperature is going to be like very small. Okay. So what is like critical temperature? Above that temperature, you can't liquefy the gas. That is critical temperature. Since this critical temperature is like very small, okay, so it is going to be like you can't liquefy those gases. But when you take like HCl, here hydrogen and fluorine gets combined. Okay, so here you can liquefy it easily. Okay. So whenever like they are monatomic gases or whenever it is a noble gas, those gases are difficult to liquefy. They are difficult to liquefy. Okay, so therefore this option is like right. So B and C are the incorrect statements. So options are going to be like B and C. Okay, clear with this question? So this whole part is from gaseous state. Clear? Yes. Moving with the next question. Yes, look over this question. 20 ml of KOH solution was titrated with 0.2 mole liter inverse H2SO4 solution in a conductivity cell. The data obtained were plotted to give the graph shown below. What is the concentration of KOH of the solution? What you're going to do is like you're going to titrate KOH versus H2SO4. Okay, in a conductivity cell, the data obtained is given over here. And from the data, you could understand like what is the equivalence point over here? Like 15 is the equivalence point, this point. Okay, the relative conductivity, where the relative conductivity is minimum. The volume at which the relative conductivity is minimum is your equivalence point. Equivalence point. So the equivalence point is going to be 15 ml. So this is the data what we got from the graph. You have to find out the concentration of the KOH. Concentration of the KOH. Okay. So now the equivalence point, that is the volume of acid added. What is the equivalence point is at 15 ml, it gets like neutralized. That is the concept over here. So what is the volume of acid added for the equivalence point is 15 ml. So I can say it as like V1, okay, and mole liter inverse is given. So M1 into the equivalent factor NF is equal to the volume into what you need is the concentration. Concentration into the NF factor. Okay, so this whole thing is for the acid and this whole thing is for the base. Just you're doing the equivalence concept over here. Okay, so can you solve and give the answer now? Like all the data is in the question. Just solve and give the answer. All the data is in the question for the acid and base. What you are going to do over here is like equivalence of acid is equal to equivalence of base. Yes. Okay. Yes, very good. It is like option number A. Option A is the right answer. Okay. So we'll solve it. Like volume. What is the volume of acid? We have got it as 15 ml. And what is the molarity of the acid given as 0.2 into NF. So for H2SO4, what is the NF value? It will give you 2H plus HO4 2 minus. So 2 is the NF value. What is NF? The number of H plus ions gives them. Okay, is equal to volume of base 20 ml of KOH is given in the question. Into concentration is what we are going to do. And what is the NF for KOH? KOH will dissociate into K plus OH minus. So how many OH minus it can give out? Like 1. So into 1. So what will be C? Just evaluate it. 10 times. Okay. So C is going to be like 0.3 mole liter inverse. So option A is going to be the right. Okay. Got with this question, everyone? Clear? Clear with this question? Any doubt? Clear? Yes. So moving to the next question. for the reaction, NH3 gives half N2 plus 3H2. If Kp of the above reaction is 78.1 at 400 degrees Celsius, which is not correct. At pressure P, degree of dissociation of NH3 is given. Kc value is given. If we increase pressure, Kp remains constant. If we increase pressure by bringing piston down, then the degree of dissociation will decrease. Okay, so these are the options given. Like, can you guess the option which is going to be the right answer? Kp is given. Okay, so what would be the degree of dissociation? Just evaluate the degree of dissociation. What would be the Kc value? And if you increase the pressure, Kp remain constant. If you increase pressure by bringing the piston down, then what happens to the degree of dissociation? Yes, so what is the equation given as? NH3 gives half N2 plus 3 by 2 times of H. Okay, so now I am taking this number of moles is not given, so I am considering it as like A. Time is equal to 0. At time is equal to T. So here N moles are given, right? So N moles into 1 minus A. Here I can write it as like N A by 2. Up is there. So here N into A into 3 by 2. So now what would be the partial pressure at equation? So what would be the partial pressure of each and everything in the equation? So what would be the partial pressure? What is partial pressure? It is the pressure of each and every gas present. Okay. So it is like what is there? What is here? It is first calculate the total pressure. Okay. So total pressure, like leaving the number of moles. Number of moles is for the concentration. So what would be the total pressure is like 1 minus alpha. I make it as alpha. So we'll get the degree of dissociation. So 1 minus alpha plus alpha by 2 plus 3 by 2 into alpha. So now what would be the total pressure? What would be the total pressure? So just evaluate this one. Okay. So you'll be getting it as like 1 minus two times. So 2 alpha plus alpha plus 3 alpha. Okay. So it is going to be like what you'll be getting 3, 4, 5, 6 alpha. Oh, here product is there. So product you have to minus it. Product you have to minus it. So So 1 minus 2 times of alpha plus 3 times of alpha by 2. So what you'll be getting over here is like 3 and 6 alpha by 2. Okay, so 1 minus 6 alpha by 2, which is 1 minus 3 alpha. Okay, so now you can write the total pressure. You can write the total pressure. So what would be the total pressure? Minus what would be the total pressure? So total pressure is like individual pressure, vapor pressure of each and everything will be like the individual pressure by the total pressure. So what is the individual pressure of this one is 1 minus alpha by 1 minus 3 times of alpha. Here it will be like 1 minus, for NH3, For NH3, it is what you have 1 minus alpha. So 1 minus alpha by 1 minus 3 times of alpha. Here you'll be getting like 1 minus alpha by 1 by 2 into 1 minus 3 times of alpha, and this one is like alpha, right? So alpha, and here it is 3 by 2 alpha. So 3 times of alpha by 2 into 1 minus 3 times of alpha. Okay, so this is what you got. Now what you have to do is like you have to calculate Kp. Okay, you have to calculate Kp. So what will be like Kp? Pressure of N2 to the power 1 by 2, pressure of H2 to the power 3 by 2 by the reactant, just PNH2. PNH. Okay, so just now we know that these are the vapor pressure of the things. Okay, you have to just substitute over here and find out alpha. Okay, if you're doing this, you'll be getting this one. I'm not going to evaluate. Time is up. So I'm just giving you the hint. Okay, so therefore you'll be getting this. So option A is going to be like right. And how will you get Kc? Kp is equal to Kc into RT per delta Ng. Yes, so we know the Kp value. From this, like you'll be getting the Kp value. Kp is equal to Kc into RT per delta Ng. Or how will you do delta Ng? Product, the number of moles of product minus number of moles of reactant. So it will be like 1 by 2 plus 3 by 2 minus 1. Okay. So then if you evaluate, you will be getting like this will also be fine. Okay. Now, if you increase the pressure, will the Kp remain constant? From this, like you can see, when you increase the pressure, okay. So when you increase the pressure, will this Kp remains constant? No, it will not remain constant. So option C is going to be the incorrect statement, while A, B, and D are going to be the right one. Okay, so just evaluate it. I have given you the hint for this question. So moving to the next question. Positron is a species consisting of an electron bound to a positron. The ionization potential of positron is A electron volt. Then the value of A by 3.4 will be. Okay, positron is a positronium. Positronium is a species consisting of an electron bound to a positron. So electron and positron. Okay, so you're bounding it. So therefore, you have to calculate mu, which is mass of electron into mass of positron by mass of electron plus mass of positron. Yes. So when you do this one, you'll be getting like the whole thing. I'm taking it as Me by 2. Okay. So I'm taking this as like Me by 2 because here you have like mass of electron into mass of positron by mass of electron plus mass of positron. Okay, so the whole thing will be like Me by 2. Now we are doing the ionization potential is 13.6 into mu by Me. So 13.6 into mu is Me by 2 by Me. So which is going to be like 6.8 electron volt. So your answer will be 6.8 by 3.4, which is equal to 2. So answer will be equal to 2. Okay. And moving to the next question, we have like some 3 to 4 questions to solve. Okay, we'll complete in 15 minutes. Right. This question is pKa, pKa2, pKa3 of H3PO4 are given as 4, 8, 12 respectively at temperature T. To a 50 ml of solution of 0.1 m Na3PO4, 50 ml 0.2 m HCl is added. Find the pH of the mixture obtained. Okay, so what you have taken is H3PO4's Ka value is given. So if you dissociate like 1H plus, you'll be getting HPO4 minus, whose pKa value is 4. Now again, you're taking HPO4 minus, sorry, H2PO4 minus. H2PO4 minus will again give H plus to form HPO4 2 minus, whose pKa is 8. Again, this HPO4 2 minus will give H plus PO4 3 minus, whose pKa 3 is equal to 2. Okay, so these are the pKa values. If you remove like 1 H plus, the pKa value is 4. If you are removing like 2 H plus, 8. If you are removing 3 H plus, it is going to be like 12. To a 50 ml of solution of 0.1 m Na3PO4. So Na3PO4, I'll write the ionic form as PO4 3 minus. PO4 3 minus. Okay, it will react to 50 ml of 0.2 m HCl. You are adding HCl. Okay, you are adding HCl. Now you have to find out like which among this will be formed. Which among this will be formed. Okay, so that is what you're going to find out. Now, for if you are adding, it is like 0.1 m. 0.1. So if you add one more 0.1 m of HCl, it will take like the number of moles is going to be C. Then what you'll be getting? You'll be getting like PO4 2 minus. HPO4 2 minus will be getting this one. What is given in the question is 0.2 m. It means that you're adding one more 0.1 m HCl. I'm adding one more HCl. So if I add like HPO4 2 minus, I add one more H plus, you'll be getting what? H2PO4 minus. H2PO4 minus. I'll be getting this. Okay. So therefore, this is like 0.1 m HCl. So if I add one 0.1 m HCl, I'm getting HPO4 2 minus. If you add like one more 0.1 m HCl, we'll be getting H2PO4 minus. Okay, so now we'll write the overall equation. PO4 3 minus plus how many HCl you are added? 2 times of HCl. I'm writing the stoichiometric equation to give H2PO4 minus. Okay, you will be getting this. Now, what is given in the question? 0.1 m. What is given? 0.1 m. Okay, so at time t is equal to 0, 0.1 m of 50 ml HCl. 0.1 m of 50 ml. So what would be the number of moles? 0.1 into 50 is equal to 5. So number of moles is going to be 5. Number of moles is going to be 5. Now again, for HCl, what would be the number of moles? 50 into 0.2. 50 into 0.2 is equal to 10. So 10 moles. So when 5 moles of PO4 3 minus reacts with 2 moles of HCl, you are getting 1 mole of H2PO4 2 minus. So when you are reacting 5 moles of PO4 3 minus to 2 moles of HCl, how many moles of H2PO4 you will be getting? Here the ratio is like 1:1. So 5 moles. You will be getting like 5 moles of H2PO4 2 minus. H2PO4 2 minus. Now what you want is like find the pH of the mixture obtained. So what would be the pH? What I'm going to do? You are going to add like the dissociation constant. So if you add 1, you are going to add like 2. Okay, you're going to add 2 times of H plus because 2 times of HCl you're adding. So what you have to do is like add these two. So pKa 1 plus pKa 2 by 2 will give you the pH. So 4 plus 8 by, so the value would be equal to 6. The pH value is going to be like 6 will be your answer. Okay. So this question is like somewhat tricky question. Are you clear with this question? Like any doubt with this question? Do you have like any doubt? Clear with this question? Shall I move to the next question? Yes. Moving with the next question. Okay. So molten NaCl on electrolysis gives a cathode product. This we have studied in electrochemistry. Molten NaCl and aqueous NaCl, we have got like 2 different products will be getting. Which on the cathode product, when you react it with excess of O2, you'll give A. And on reaction with base will be getting B plus C. C on reaction with I2 and KOH gives I minus. If the molar mass of C, this product is P, find the value of P. So for this, you have to write the equation first. So when molten NaCl in aqueous state, yes, when it undergoes the electrolysis. So it is not aqueous, it is molten NaCl. Molten NaCl. So molten NaCl, it will give you what is molten NaCl will give you. What are the products formed during molten NaCl when it undergoes electrolysis? What is deposited at cathode and what is deposited at anode? At anode, sodium will get liberated, and at cathode, sodium will get deposited, and at cathode, Cl2 will get liberated. Now, what is the cathode product? Cl2. You are reacting it with excess of O2. When you react it with excess of O2, what is the product you will be getting? Like if I'm taking it as 1 mole, you will be reacting it with 2 moles of O2, which is excess. Okay. So what product you will be getting? You will be getting like ClO2 2 times. So 2 times of ClO2 is the product you will be getting. Now what I'm going to do is like react ClO2 plus H2O. What is the product you will be getting? Like you have ClO2, ClO2. Yes, you are reacting with H2O. So what happens over here? Like hydrogen will take up Cl and it will be removed as HCl. So what else you'll be having? You'll be having like H. You are taking 2 times, okay? 2 times of ClO. So HClO3 will be getting HClO3 as the top. And if the one thing is basic, the other one will be like acidic. Which is acidic? HCl is acidic. What is the molar mass of HCl? It is 36.5. So the answer is going to be like 37. Is the option. Okay, got this question? And what is the maximum number of cyclic isomers possible with the formula C5H10? So you have to draw the number of cyclic isomers for C5H10. So write the isomers and count how many cyclic isomers are possible. Just count the number of isomers for C5H10. Go with 3-member cycle. So you'll get it like 3-member cycle and then 4-member cycle and 5-member cycle. C5H10. So if I draw like 3-member cycle, if you draw 3-member cycle, okay, so it is going to be like C3H6. You need like 2 CH3 added. It could be added to the same carbon or it could be added to the adjacent carbon. Now, like both are sp3 hybridized and have like 2 different groups attached. So therefore, it can show like cis and trans. It can show like cis and trans. Okay. Yes. And this is for 3-membered. 3-membered. Now, when you go for a 4-membered ring, so C4H8, C4H8, when I write like CH3, it is not going to be C5H10. It will be like C5H. Yes, you'll be getting like C5H10 only. Yes. So you'll be getting CH2, 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 and here it will be like CH. So 3, 4, 5, 6, 7, 8, 9. So I'll be getting like one thing like this. Yes. And if you move for a 5-membered ring, C5H10, C5H, this is like one more isomer. So how many isomers you have got? Like 1, 2, 3, 4, and 5. So the answer is going to be like 5. Okay, got this question? And Yes, consider stereoisomers also. Fine. So like this is stereoisomer. Okay, you'll be getting like cis trans. And when there is like a chiral center, you'll be getting the stereoisomer, yes, optical isomer. Like when you take this one, okay, you have like hydrogen, CH3, CH2, CH2 on both sides. So it is not a chiral center. Here too, there is no chiral center, no chiral center. Here too, there is no chiral center because the thing which is like here, it is attached to the same thing. Here you can write. Here you can write. Okay, so considering stereoisomers only, you have got like 1. Okay, yes. Moving with the next one. Identify the number of compounds from the following which liberate CO2 on reaction with them. So which one will liberate CO2? We know that when this Na2CO3 is reacting NaHCO3 bicarbonate. Bicarbonate with carboxylic acid will liberate CO2 gas. Yes. So which one will liberate? Here you have carboxylic acid, it will liberate. Will phenol liberate? No. It will SO3H liberate? Yes. And here COOH is there, it will liberate. COH liberate. Here it will not liberate. Here it will liberate, it will not liberate. So the answer is going to be like 1, 2, 3, 4, 5. So the answer is 5. Okay. And next one is like the total number of reagents from those given below that can convert nitrobenzene into aniline. So which one will convert nitrobenzene to aniline? NO2 to NH2. NO2 to NH2. So 10HCl, yes. So it is a good reducing agent. In the presence of acid, it will give the aniline. But here you can see that there is a presence of base, so it will not give. Fe plus HCl will give, zinc plus HCl will give hydrogen, palladium. All these are like reducing agent. So therefore, except 10NH4OH, all the others can give the convert nitrobenzene into aniline. So the answer is going to be like, okay, yes. And is there like no chiral center in the second site? Fine, I'll check it. When you move to the second one, here you have like CH3, hydrogen, CH2, CH2. Here, can you see you have CH3 attached, and again you have like CH3 carbon containing CH3 hydrogen. Okay, and like there is some sort of symmetry over here. Okay, so you can see like when I do the rotation, it will have like some axis of symmetry. So what is the condition for the optical activity? It should have the chiral center and there should be no symmetry. That is, no plane of symmetry should be there, axis of symmetry should be there, center of symmetry should be there. Okay. So like since there is some sort of symmetry, it will not give the optical isomer. It will give only the stereo isomer. Okay, clear now? Yes, fine. So these are the questions in the paper 1. Okay, we have no time to discuss paper 2. I'll stop over here and I'll send this PDF in the group. Okay, go through this PDF once again. Fine. And like in tomorrow's class, which topic thing and come back. Okay. Okay, wait a second. I'll check like tomorrow which chapter we'll be discussing. So go through the chapter once and we'll be discussing the questions alone here. Okay, so tomorrow we'll be discussing the aldehyde, ketone, and carboxylic acid unit. Okay, so aldehyde, ketone, and carboxylic acid tomorrow we'll be discussing. So go through the unit and we'll be discussing the questions based on. Okay, fine. So you can leave now. Thank you all. Thank you, everyone.